All right, so this is practice on learning target number 3. Learning target number 3 uses these formulas. You will need to know those formulas. It also involves taking perfect squares and perfect cubes and rewriting them with a lower base. And it also involves you being able to determine if an expression is positive or negative. So there's a lot going on here. Let me show you the answers. So in number 1, I gave the formula, the equation, and the answer. I guess I'll just let you give the answers, huh? And then we'll talk about them. My numbers didn't quite go in order there, did they? All right. So, you have got to know these formulas for the test. I hope you have them. Let me go ahead and start doing some problems with them. All right, so in problem number 1, I've got the area of a square garden in Emily's backyard is 160 square feet, and I want to know how long is one side. So I need the formula which deals with area and side length. My formula would be area equals side squared, and then when I substitute the numbers from the problem, 160 is the area, so I'd put that in for A, and that would equal side squared. There is what the equation looks like when you substitute the numbers from the problem into the formula. And now to solve this, you would take the square root of both sides. And you would get S equals the square root of 160 rounded to the nearest tenth is 12.6. So, one side would be 12.6. Now I need to get the correct units. The units are feet, and side length would be measured in regular units, so it'd be 12.6 feet. Problem 2. Problem 2 says the area of a square window is 60 feet squared. Find the perimeter. Uh-oh. I've messed you up on this one. This one's going to take 2 formulas. So the area and the perimeter, we do not have a formula that does both area and perimeter. All right, we're going to have to use the area to find the side length, and then the side length to find the perimeter. So my first formula is going to be area equals side length squared. And they gave me the area, so I can go ahead and substitute that in and say 60 equals side length squared. And now I have the equation using the numbers in the problem. And to solve this, I would take the square root of both sides and find out the side length is the square root of 60, and that is 7.7. Now, instead of writing another equation, I'm going to need another formula, and that would be the perimeter formula. Perimeter equals 4 times the side length. So my equation would be perimeter equals 4 times 7.7. I'm taking my side length of 7.7 and I'm putting it in for the S side length. And so then all I need to do is multiply 4 times 7.7, and I would find out that it's 30.8. Now all I need is the correct units. The units are feet. Perimeter is a length, so just like side length, the perimeter is going to be measured in regular feet. Problem number 3. I am building a deck. I have enough space for the side of the deck to be 14 feet. What will the area be? So I have the side length. I want the area. That, again, is going to be the area formula. Area equals side squared. And I was given the side length, so that'll go in for S. And I will have area equals 14 squared. And now I can solve that for the area. I simply need to square the 14, which is 196. And since this is area, I know that area is measured in square feet. 196 square feet. Part B says, the wood planks that I want to build my patio out of cost $2.50 per square foot. All right, so the important thing here is that's per square foot. Well, how many square feet am I buying? 196 square feet. So it's $2.50 for each of the 196 square feet. That would be $2.50 times 196. And that turns out to be $490. A pretty expensive back patio. And one more of these. Grace is buying carpet for her family room. Each side of her room is 12 feet. How much carpet will she purchase? Well, carpet covers, again, this is a little tough to see in this problem, but carpet covers area. You don't have a length of carpet, you have an area of carpet. So this is another area problem. My formula would be area equals side squared. And the equation I would use, let's see, this 12 feet is side length, right? So it would go in for S. And I would have A equals 12 squared for my equation. And I can go ahead and solve that just by squaring the 12, which is 144. The area is 144. And once again, I know area is measured in square feet. All right, this next skill is rewriting problems. I only have one problem like this. I'm not sure that's enough, but this one problem does involve everything you need to know how to do. The 27 is a perfect cube. So because it's a perfect cube, I can rewrite it and reduce the base. Anytime you have a perfect square or perfect cube, you can rewrite it. 27 can be rewritten as something cubed, and it would be 3 cubed. But 3 cubed is just taking the place of the 27. The 8 would still be on it. So then I would go ahead and simplify this by doing the power to a power, and I would get 3 to the 24th. Now, 3 to the 10th cannot be simplified because its base is not a perfect square or perfect cube. But 9 can. 9 can be rewritten as 3 squared because 9 is a perfect square. So I can change it to something squared, 3. But the 9 has a 7 on it, so the 3 squared has to have a 7 on it, making this actually equal to 3 to the 14th. And finally, those two things were being multiplied together, so down here I'm going to multiply them together. And when we multiply, we add the exponents. That would be 3 to the 24th. So it turns out these two amounts are actually equal to each other once I simplify them. And last, this brings me to positive and negative, right? All right, let's see. I have an expression here, 15 times x to the 14th power. Well, I like to separate that, as you know. And I'm trying to determine, when I multiply this times this, Will the answer be positive or negative? Well, that might depend on what I put in for x. I know the 15 is a positive number. I'm not sure if this is positive or negative. It might depend on what I put in for x. Part A says, put a negative number in for x. Well, we learned that when you have a negative number to an even exponent, like say negative 7 to the 14th power, since 14 is an even exponent, all the negative 7s multiplied together would pair up evenly, and each pair would be positive. An even exponent turns the expression positive. So a negative number in for x to the 14th power would be positive, and a positive times a positive would be a positive. All right. How about if I put a positive number in for x? Like say, like say if I put the number 7 in there to the 14th power. Well, all right, let's start with the 15. The 15 is still a positive number. If you put a positive number in for x, positive numbers are always positive. So you'd have a positive times a positive, and it would still be a positive result, right? And this leaves us with just the 0. So if you replaced x with 0, now you'd have 15 times 0, because 0 to the 14th power would be 0, and 15 times 0 would be 0, and the result would be 0. All right, let's look at number 10. I'm going to go through the same process. I'm going to take this expression and I'm going to rewrite it as negative 11 times x to the 17th. Now in this case, I'm starting with a negative number. 11 is a negative number. X to the 17th, I don't know if that's positive or negative. It might depend on what I put in for x. And it says for me to start with part A, replace x with a negative. So if I put a negative number in for x, like negative 2 to the 17th, a negative number to an odd exponent is negative. I don't know what number it is, but I know it's a negative number, and that's all I really need. So what I end up with here is a negative 11 times a negative something, a negative times a negative, and that's positive. So when a negative number goes in for x, the final result is positive. All right, let's try putting a positive number in for x. So the negative 11, still negative, but as we all know, when you put a positive number to any exponent, positive numbers stay positive. So a positive number like 2 to the 17th power is still going to be positive. This x to the 17th, when x is a positive number, would be a positive result. But now you've got this negative 11 times this positive, and a negative times a positive is negative. The final result ends up negative. And last up, when we put 0 in for x, I'd end up with negative 11 times 0, and of course that is 0. All right, guys, good luck on the test.